Hey guys, sorry I couldn't be there today, but we're still gonna keep going. I know the stuff's gonna tell you this, but just to make sure you know, this is one of the last Hawks sections before we take the second Hawks test, so make sure you get any missing Hawks done. You're gonna need to complete 5.4 today, and then we only have one left, so just keep that on your radar. So today we're talking about the fundamental theorem of algebra. The Hawks is pretty short, but I gave you guys some guided notes. You can pause the video whenever you want, and just kind of fill it out from there. So 0 is a polynomial function. If f is a polynomial function and a is a real number, the following statements are equivalent. X equals a is a 0 of the function. X equals a is a solution of the polynomial equation. X minus a is a factor of the polynomial. And a comma 0 is an X intercept. So stuff that we've all talked about before. We use 0, solution, factor, X intercept kind of interchangeably, but they all mean the same thing. It's just how you write it. So the fundamental theorem of algebra, which we've kind of talked about before, I just never really called it by its name. The number of solutions to any polynomial equation is always equal to the degree of that equation when you account for multiplicity. So those solutions can be real or complex, and then we'll talk about the factors part when we get into it. So here's some examples. It says find all the real zeros of the polynomial function and determine the multiplicity of each zero, then write it in factored form. So like this one right here, we need to factor out 2x squared. So I'd have x squared minus 10. So then I would say 2x squared equals 0, x squared minus 10 equals 0. So those are two answers right there, plus or minus the square root of 10. And the other answer would just be 0. That has a multiplicity of 2. Because the exponent on that one is a 2. Whereas this one you have a positive square root of 10 and a negative square root of 10. So they each have a multiplicity of 1. Next one, I'd probably factor out a 4x to start with. I have x squared minus 2x plus 1. So I'd factor into x minus 1 squared. So that one has a multiplicity of 1, because it only shows up one time. Whereas this other one, 1 has a multiplicity of 2, because it shows up twice, because it's got the squared on the outside. Alright, so like, see this one's a little bit different than this one. The squared was on the inside. This one, it was on the outside, so that means that's the multiplicity. Next one I would do negative 2 x to the third. So I have x squared minus 9. Alright, plus 9. So then I would set this equal to 0. I get x equals 0 with a multiplicity of 3. And x squared plus 9 equals 0. So this one, don't forget when you square root a negative, you have to write an I with it, so that's an imaginary root. So again, you can have a real one or an imaginary one, but the big thing is you find all the real zeros, and those just have a multiplicity of 1. This doesn't really show up on the Hawks today, it's just kind of nice to know. It kind of ties into factoring stuff. So here is one of the problems you will see. It says find all real zeros of a polynomial function. I believe this is on your last page, if I remember correctly, of your notes. So I'm just trying to see if there's another example of it. There's not, but I think I've already got this one typed on Desmos. Or maybe the one that you guys have is typed in on Desmos, I can't remember. So I think this is the one on your notes. So I'll kind of tie it into what we're doing. So notice there's 4 zeros. It's just 2 of them are decimals, and the other ones are real ones. So here's what you're going to do on this problem. When you see this on the Hawks, you're going to graph it on Desmos, and you're going to find the real zeros. So this one will be negative 1 and 2. And so this one I kind of gave you the hint. I would graph this on Desmos, and I would take the zeros that are whole numbers, and I would do synthetic division. So negative 2. That should be a positive 12. Try to do this really early in the morning, guys. I don't feel very good. 24, negative 48, and 0. So you should have a remainder of 0. So then I would write x cubed minus 4x squared minus 6x plus 24. So then I would also do the other real 0, the one that's not a decimal, of 4, and do synthetic division with what I got for my answer. So I got 1, negative 4, negative 6, 24. So then you end up with x squared minus 6 as your leftover part. So I know whenever I factor this that I'm going to have x plus 2 and x minus 4. This is what's left over. So after I do synthetic division on both those, that's what's left over. Because we already know these are zeros, because whenever you graph it on Desmos, that's where it crosses the x-axis at. So then I'd take this one, I would set it equal to 0. I would square root it. So it would be plus or minus the square root of 6. So to write your answers, you would do negative 2 comma 0, 4 comma 0, square root of 6 comma 0, and negative square root of 6 comma 0. And on this problem, you are going to have something that's going to have a square root with it. That's why you're going to get those decimal answers. So again, the one on the notes is also on Google Classroom on the student notes, and you can check that one. I just did an example here real quick, and that's kind of what goes into that first part of that question. I think there's only 3 questions on the Hawks, but they all have like 3 or 4 parts. So the other thing we're going to talk about is the connection between multiplicity and x intercepts. This is what are the zeros slash x intercepts and their multiplicity. So the zeros would be negative 1 comma 0, so I would set that equal to 0, 1 comma 0, and 3 comma 0. And I'm going to write a little m out to the side. It represents their multiplicity. Negative 1 has a multiplicity of 2, 1 has a multiplicity of 1, and 3 has a multiplicity of 3. All right, and that's really just the exponent that tells you the multiplicity. So it says, how will you describe the graph of those x-intercepts? Well, if you look at 2, the multiplicity of 2, negative 1, do you see how it touches it and then it goes back up? If it has a multiplicity of 1, it crosses. If it has a multiplicity of 3, it crosses, but it also flattens out. You see how it flattens out and then it crosses? So the big thing is we're going to make a connection here whenever we do these charts. So I would have you, normally if we were there, graph these on Desmos, and then we would talk about them. But instead I'm just going to talk about how to find the degree and the y-intercept. So the degree is just adding up the exponents. So there's a 1, 1, 1. So my degree would be a 3. Now your y-intercept, you would take 2 to the multiplicity. So in this case it's just 2 to the first times 1 to the first times negative 3 to the first. So it's all really just multiplying 2 times 1 times negative 3, which would be negative 6. And I bet if you graphed it on Desmos, that's what you would get. So the zeros, you would have negative 2 comma 0 with a multiplicity of 1. You would have negative 1 comma 0 with a multiplicity of 1. And you'd have 3 comma 0 with a multiplicity of 1. So it says, does the graph cross the x-axis at these zeros? If you graphed it, you would say yes on Desmos. And it says, does it flatten out? The answer on all these would be a no, because the multiplicity of 1 is just like that. So then we go to the next one. The degree would be a 3, because I do 1 plus 2. And then my y-intercept, I would do 3 to the first times negative 5 to the second. So that would be 25 times 3, which is 75. And it is possible for your y-intercept to be that big. It's just the way it works out sometimes. Alright. So then I would do my zeros. That would be negative 3, comma 0, and 5, comma 0. This one has a multiplicity of 2. This one has a multiplicity of 1. It says, does it cross the x-axis? This one would be a yes. This one would be a no. This does it flatten out. This would be a no. This would be a yes. And again, you would just graph that and see, okay, here's what happens. So next one, I would say the degree is 6, because I would do 2 plus 3 plus 1. And then to find the y-intercept, I would take 1 squared times negative 2 to the third times negative 1. So when you do that, you would get negative 2 to the third is negative 8, times negative 1 is 8, times 1 squared is 8. So it would be 0, comma 8 as your y-intercept. So then again, I would do the zeros with their multiplicity, negative 1, comma 0 with a multiplicity of 2, 2, comma 0 with a multiplicity of 3, 1, comma 0 with a multiplicity of 1. So it says, does it cross? If it's odd, hopefully you're kind of starting to see a pattern here, it should cross. And if it flattens out, it's just got to be bigger than 1. So again, you're going to start seeing patterns when you do these. The more you do them, the more you see. So the next one, the degree would be 6. So I would do 3 times negative 2 to the fifth to find my y-intercept. And guys, I don't have a calculator on me, so I'm going to say it's negative 64, negative 96, but that's just me guessing off of what I do with mental math. I don't remember exactly. So again, you would graph that, see what it is. You can fill it out with the notes that are on Google Classroom as well. They're completed on there. So then I would do -3, 0, 2, 0. This one has a multiplicity of 5. This one has a multiplicity of 1. It says, does it cross? They both will cross because they're both odd. It says, does it flatten out? The answer would be no on the multiplicity of 1. But if it's bigger than 1, it should flatten out. So, okay, you should start to see some patterns here whenever you do this. So the next one, I'm not going to fill out, but you would do it on the notes. You can look at it and fill them out. So then it says the geometric meaning of multiplicity. If it crosses the x-axis, your multiplicity is odd. And then if it's going to be flatten out, which is going to be a question on the Hawk, so you're going to see, does it cross, does it flatten out? You're going to have a question on both those. Flatten out would be anything bigger than 1. So here's an example. It says the degree and y-intercept of the function. So the degree would be 5, 6. The y-intercept, I would do 3 squared times -1 cubed times -2. So when you do that, you would get 9 times -1 times -2, which would be 18. If you look at it, it's up here. It doesn't really show it, but my y-intercept should be 18. Okay, the zeros, x-intercepts, the zeros would be -3, 0, 1, 0, and 2, 0. So then the multiplicity, this one has a multiplicity of 2, this one has a multiplicity of 3, this one has a multiplicity of 1. Now it says, at which x-intercepts does it cross the x-axis? Well, if you look at it, where does it cross it at? Well, it's at the ones that are going to be odd, so it should cross it at 1 and 2. Well, if I look at it, it crosses here, and it crosses here. So I was going this way, it crossed it, I was going back up, and it crossed it. So it crosses at these 2 zeros. So it crosses, which is going to be a question on the Hawks, at 1, 0, and 2, 0. And then if it says, where does it flatten out at? Flattens out at anything bigger than 1. So it should flatten out at this one. So you see it kind of flattens out, and it goes back up, and then it flattens out at this one. So the flatten out ones would be these 2. So you can use the same 0 more than once. So you see how 1, 0 crosses and flattens out, and it may be that problem. So that's kind of the general idea of it. I put another one of these up here. Okay, this is one that you have on your notes that you would do. You find your real zeros, -1 and 2. So then I would do synthetic division, -1. This would be -2, 2, -2. Again, you should get a remainder of 0 if it's actually a real 0. So then I have x cubed minus 2x squared minus 2x plus 4. So then I figure out the other one, which would be 2. Again, you only use Desmos on this problem just because you have to do this type of factoring. So then I have x squared minus 2. I would also have x plus 1 and x minus 2 when I factor it. So then it says the degree, okay, we know the degree is going to be a 4 based off the original problem. The y-intercept on this one is kind of nice. It's just the last number, which is 4. So 0, 4. So whenever you see this problem on the Hawks, it's probably the toughest one on the Hawks. Just that last number. And it says, what are the x-intercepts? So the x-intercepts would be -1, 0, 2, 0. Those are the easy ones. And then this one you have to do synthetic division to get to, and then you would set it equal to 0, and then you would square root it. So you'd have plus or minus square root of 2. So you'd say negative square root of 2, 0, positive square root of 2, 0. So that would be your 4 x-intercepts, and that's why these are decimals right here on these ones. So the ones that I circled in black would be those. And it says, which ones cross? Well, if you look at it, don't they all cross because they all have an odd multiplicity, and they all just have a multiplicity of 1. So they're all going to cross. So you would select all of them, put all of them in there for crossing. And it says, do any of them flatten out? Well, the answer is no, because none of them have a multiplicity bigger than 1. So if it's just a multiplicity of 1, they don't flatten out. So your answer for number 3 right here would be be all of them. So I would type in this answer again for number 3, and then number 4 would be none. You would just select 0 on the